Hi everyone, this is the first video for section 1.2, more problem solving strategies. And so this chapter, this section goes over more problem solving strategies. So make sure, if you haven't already, go back and read section 1.2 so that you're familiar with some of the problem solving strategies before we do these examples. Okay, so before we went into the different strategies from section 1.2, I wanted to just go over the four-step approach to problem solving one more time. So remember, the first step is to understand the problem. So to do this, we need to know what information is given and what information do we need. So what information are given? What information do we need? What is the question really asking? So once we understand that problem, we devise a plan where we pick our problem solving strategy. So we pick our problem solving strategy. So we have some from section 1.1. We're about to go over some more from section 1.2. Okay, and so then we solve the problem, and while we're solving the problem, we will monitor our plan. So in this step, we make sure we understand. So we make sure we understand every step. So math is very methodical, right? Every step we take has a reason, Make sure we understand every step. So math is methodical, it has a reason. Make sure you understand why you're doing what you're doing, because there's always a reason to it, or at least there should be. And finally, once we're done solving the problem, we look back over our work and we ask, does our answer make sense? Does it make logical sense, right? Any real world problem has to make sense in the context of the real world. We can't have negative time or money. We can't have 300,000 story buildings. We can't have these things that just seem like they aren't right. It means you probably made a mistake somewhere. Mistakes in math are really common. They're really easy to make, and they're nothing to be ashamed of. Mathematicians make mistakes all the time, so it's okay if you as college students make mistakes. So the first strategy we're going to go over from section 1.2 is drawing a diagram. So this is covered on pages 13 and 14 of the textbook. So we're going to go over a question on it here, an example here. Okay, so in this strategy, we're going to draw a diagram. So we are told in our word problem that passengers enter the elevator building. The elevator moves down 8 floors, stops, moves up 3 floors, stops again, moves down 12 floors, and then finally stops. That should say then. My apologies, yours will be fixed. And then stops. So the elevator is now 2 floors above the bottom floor. And we want to just kind of get a scope of this building. What does it look like? How many floors are there if the passengers enter on the top floor? So it's kind of a lot of words, and it's okay to be overwhelmed by them. So let's draw a picture, right? That seems natural to me to kind of say what's happening with all this down and up motion. So we have passengers get in on this floor, and then they move down 8 floors. So there's 8 floors between where they got on and where it stopped. Okay, so now it stops, and now it moves up 3 floors, right? It went up 3 floors from where it stopped. Okay, now after it moves 3 floors and stops, we have that it moves down 12 floors. And then it stops. So now we know that the elevator is 2 floors above the bottom. So right here is the bottom floor. And we know that the passengers entered the elevator over here on the top floor. So we want to know how many total floors there are in this building. So I see really 2 chunks, right? So we have this section of 12 and 2. And then we also have this section up here that is where they originally went down 8 floors. So it's this section here. So we can see that that was where they originally went down 8 floors and back up 3 floors. So in this gap, there should be 5 floors. And so then we have every floor covered from the top to the bottom. So there are 5 plus 12 plus 2, which is 19 floors in the building. So if there are 19 floors, let's explain our reasoning. So we drew this diagram, but it's always a good idea to go ahead and add a little bit more words to explain why. So let's explain why. So the passengers entered on the 19th floor and then they went to the 11th and then they went to the 14th and finally down to the 2nd. Right, and this makes sense. This is also a good way to check your work. So if they entered on the 19th floor, they went down 8 floors to the 11th floor. Then they went up 3 floors to the 14th. Then they went down 12 to the 2nd floor, and that's exactly where they should be, 2 floors above the bottom floor. And so that's this one. So anytime you have a building or really just any physical object, right? So the 2 examples in the book were dealing with bridges and storage boxes. So anytime you have any physical object like this, it's a really good idea to draw a diagram or a picture to just kind of help you visualize what's going on when there's movement like this. Okay, that is all for this first page. So that's all for this video.